So let's take a look at this problem. It says adding and subtracting fractions depends on finding a common denominator. The least common denominator is the least common multiple of the denominators that occur in the computation. Find the least common denominators and compute the following additions and subtractions. So what this is saying is that if the denominators are different, we can't just add, right? So if we look at that first problem, 3/2 plus 1/8, we can't just add across. We can't go 3 plus 1 is 4 and 8 plus 2 is 10. 3/2 plus 1/8 doesn't equal 4/10. First of all, 3/2 is more than 1, right? So we're not going to wind up with a fraction as our answer. So what I'm saying is, right, if I have halves, okay, here's my shape and I've cut it into 2 pieces, right? Well, I've got 3/2, okay? So let me color this in. So I've got 1/2, 2/2, 3/2. And if I'm adding 1/8 to it, so now let me take that same shape and cut it into 8 pieces. Whoops, that's too big. I want to try and make them as close as possible at least. Okay. So if I take a rectangle and cut it into eighths, so 1/2, 4ths, now let me cut it into eighths. And I add that on, I know it's not perfect. Okay, let's say I add that eighth on. So if I've got 3/2, 1/2, 1/2, 1/2, plus 1/8, you can see when I put this together, I'm not going to wind up with 4/10. Again, if I take that rectangle and I divide it into 10 pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? If I color in 4 of them, 1, 2, 3, 4, I'm certainly not going to wind up with what I have down here, right? 3/2 is going to wind up being this one plus this one plus this one plus, my 1/8. So like a little bit more, right? That's about the size of my eighth, which is way more than even 1. I've got 1/2 plus 1/2 is going to give me a whole. So I've got more than 1.5 here, whereas 4/10 is less than 1 whole. So when we're adding fractions, we can't just add across. What we have to do is we have to find a common denominator, okay? Because as we just saw, adding across doesn't work, right? We can add the numerators together, but our denominators, we need to find a common denominator so that we can actually add them. And what this problem is saying is that the least common denominator will be the least common multiple. So as long as we can find the least common multiple of the numbers in our denominator, we can find that least common denominator. So if we look at the first problem here, we've got 3/2, let's look at it again, plus 1/8. Well, our numbers in the denominator, this problem is telling us if we can find the LCM of 2 and 8, then we'll have the LCD, we'll have the least common denominator. And in class, we learned how to find the LCM of 2 and 8. So I'm going to use intersection of sets to do that. 2 is already factored, so I know that my prime power factorization of 2 is just 2. 8, I'm going to have to do a little bit of work for. So 8 is 4 times 2, 2 is prime, and 4 is 2 times 2. Okay, I've hit all primes, so I know I can now write my prime power representation here. 8 equals 2 times 2 times 2. And so what we learned in class was, well, we can use intersection of sets to build this LCM. You could also use the prime power factorization. I'm going to use intersection of sets. I think it's visually a lot nicer. So when we're using intersection of sets, any factors that our numbers share go in the intersection, right? So they each share at least 1, 2. So that's going to go in the intersection, okay? If this is my factors of 2 and this is my factors of 8. But then 8 has 2 extra factors of 2, here and here, right? So they're going to go on the 8 side. 2 has no extra factors, so all we're going to list here is just this 2 right in the middle. And when I'm finding the LCM, I take everything, okay? I take everything in my Venn. So the LCM here is going to equal anything over here, but I don't have anything in the intersection, so 2, and then any factors on the other side of my Venn. So we have another 2 and another 2. We're going to multiply those together is 8. So what we can figure out is that our least common multiple of 2 and 8 is 8. And so we need to make sure that both of our fractions have that least common denominator, that least common multiple for their denominator. So this one's also sort of nice because, well, one of our fractions already has a denominator of 8, so we're not going to have to do any work to the second fraction. But we do need to change our first fraction a little bit, okay? So I'm going to get rid of some of this because I need more space. So we do need to change that first denominator and turn it into an 8, right? We know what our LCM is. We found it. It's 8. This fraction already has a denominator of 8, so we don't need to do anything to it. But we do need to change this 3/2 to have a denominator of 8. So I need to ask myself, what do I need to multiply by, okay, to get me 8 in the denominator, okay? What do I need to multiply by? Well, to go from 2 to 8, I need to multiply by 4, okay? 2 times 4, that gets me to 8. And whatever I do to my denominator, I have to do to my numerator. I can always multiply by a factor of 1, right? 4 over 4 is 1. 3/2 times 1 is not going to change the value. It's just going to change the way this looks. So if I multiply my denominator by 4, I better be multiplying my numerator by 4. So 3 times 4 is 12. So 3/2 is exactly the same as 12/8, only now the beauty of this is we have that denominator of 8 and we can perform the multiplication now. So instead of writing 3/2, I'm going to write 12/8, okay? And I didn't need to change my second fraction at all, so that's just going to stay 1/8, and now I can perform the addition. Okay, I know my denominator always stays the same. 12 plus 1 is 13. So 3/2 plus 1/8 is going to be 13/8. So my common denominator was 8. And when I performed the addition, the answer is 13/8. So you're going to do the exact same thing for the next two. You're going to factor 21, factor 9, build the LCM, and then identify the common denominator and perform the addition. Okay? If you have any more questions about that, let me know.